Okay, let's take a look at this next problem that we have here. It says determine the character of a load impedance if the voltage across the element is given by that equation, and the current through the element is given by that equation. So I'll write these out for us in the phasor notation, so they're a little bit easier to read. So we have the voltage is equal to 250 cosine 100 t plus an angle of 40 degrees. Okay, we look here, cosine, so we're good. So this is equal to 250 degrees, or 250 at an angle 40 degrees volts. Let's take a look at the current. The current is 15. Here it says sine. Gotta be careful. Gotta change that. So we'll subtract 90 degrees from our phase angle. So we'll change it to cosine 100 t. This here will be 15 minus 90, which will give us negative 75. So this will be 15 at angle negative 75. And that'll be amps. Okay. So now let's let's use our previous method and see what happens. So if we do Z is V over I, we get 250 at angle 40 over 15 volts over angles negative 75. That's amps. Okay, so we'll end up with 16.67 45, okay, at an angle of 115 degrees. Okay, so how do we know what this is? It doesn't really tell us. In the past we've had 90 degrees between, given elements. So 90 degrees, is for an inductor. Negative 90 degrees for a capacitor. And this is the difference between the voltages and the currents. So this is following the, here, let's write it more like this, because this is probably an easier way to set Eli the Iceman. Right? So looking at this doesn't really tell us a whole lot. But let's look at actually these up here. These will tell us something. So if we went and drew the voltage, so we'll say that's at angle 40, which is about there roughly. So 40 degrees, this is the voltage. Let's go draw the current down here. This is about 75 degrees. Okay. It's the current. So there is no 90 degree difference between the two. And the reason for that is that in the past, we've dealt with pure inductors and capacitors and resistors, but this Eli the Iceman here just is in terms of voltage and current in general. So if we look here, let's take a look at the Eli part. The voltage leads the current. Let's look at our graph. The voltage is ahead of this current. So that checks out. So we're looking at an inductor here. So an inductive load. All right. So just easy problem, easy 5%. So just compare those angles. Don't get tripped up on the fact that it's not a perfect 90 degrees. All right, I'll see you in the next problem.